Hi guys, my name is Prakpal and welcome back in my lecture number 5 of the steel structure numerical. So in this numerical, we are going to design the lap joint between the plates, two plates basically. The first plate size is 100 by 16 mm, okay, and the another plate size is 100 by 10 mm. So basically I can just give some diagrammatical representation. So 100 mm is the width and 10 mm is the thickness. Okay, this is the thickness, right? Now I'm just removing that one because this is a diagram. Similarly, you can see 100 by 16 mm is another plate which is provided below. Now we are going to prepare the lap joint. Okay. Now in the numerical it is mentioned that to transistor factored load of 110 kilonewton using single row. This is very important sentence. Using single row, this sentence is very crucial because single row brings lots of impact in the numerical. Okay, if you watch my previous video in the lecture number 4, you can see that we have used a double row. Okay, whereas it is not mentioned to use a double row, but we use a double row. That's why we make some necessary actions while designing. Now you can see that using single row of 16 mm of bolt. So we have a diameter of bolt now of grade 4.6 and grade 410 of plate. So we have a grade of plate and grade of bolt over here, right? So before starting this numerical, I would like to ask you, please do subscribe my YouTube channel Parag Pal and do visit my website civilnotes.com. This is really one of the interesting website for all civil engineers. It takes lots of effort to build this kind of websites. I hope you can visit and take the notes as a reference for you. So now let's get started. So as I had just mentioned you can see that FU is the 410, which is a plate of grade we have. FUB is the grade of the bolt, which is we calculated from this grade. Okay, so 4.6, so multiply 4 by 100, you will get the FUB. Now area of the bolt A and B you need to calculate. That is, the formula is very simple, 0.78 into AG. So gross area, this AG will become pi by 4 into diameter square. Now 0.78 multiplied by pi by 4 into 16 square, it means it gives 157 mm square, right? So that is the area of the bolt. Now DH, it means the diameter of hole, whereas you have a bolt size of 16 mm. So 16 mm plus 2 is a standardization you need to consider. It will become 18 mm. So 18 mm is the diameter of hole, whereas you are gonna put that bolt over there, right? So this is a step number 1, understand the numerical, and it will hardly take your 1 minute. After that, this numerical I have divided in the 4 stage. Okay, so first stage is to calculate VDSB. So VDSB formula, now you are got aware of that, VNSB upon gamma MB, which is FUB upon under root 3 N into ANB NS into ASB divided by 1.25, which is the partial safety factor. Put all the value because we have FUB, we have NN. Okay, so let's understand NN. Now this is a single share, right? That's why we are putting only one. We don't have the share over there. So we are putting NS value as a 0, right? So NN equals to 1. A and B we have 157, we calculate 1.25, under 3 is the standard. So you can see VDSB we got 29,006. So we can see we consider 29,000 kilonewton, right? So we have this value with us. Now the step 2 is to identify how many number of bolt required. Now understand guys, very simple concept. Whenever you are doing design for the tension, okay, for the shear, you just need to understand VDSB and VDPB. These two calculation you need to make. Whomsoever is the lowest one, that you need to consider for the design. Okay, so now we have calculated the VDSB. So based on that we are considering, let's understand how many number of bolt required, okay, for this design. So formula very simple, factored load divided by VDSB. So factored load is 110, VDSB we calculate 29, so we got 3.79. It means we consider 4 bolts. So 4 number of bolts we are going to use. Now we are arranging bolt in the single line. Why? Because mentioned in the numerical. So remember, single line we are mentioning, that's the reason there is some concept. I'll just explain you after this one. So you can see this is the plate number 1, this is the plate number 2, right? So in the both plate, what we have done, we have arranged the bolt over. This is the first bolt, second, third and fourth, right? So all these 4 bolt we provided over here. Okay, so that is a design. Now what is a design? Design means what would be the edge distance, what would be the pitch distance. So this distance we need to calculate, this distance we need to calculate basically. Okay, and that calculation will now taken place using this single row concept. So step number 4 is we need to equate the TDN. Okay, we need to equate this TDN with respect to this formula, right? So what would be the value of TDN? Now if you check my last video, I have multiplied this VDSB multiplied by 2. Why? Because we provided both in the 2 lines. But in this situation, we provided both in a single line. So we need to only take VDSB equals to VDN over here. That's the reason I have taken Newton 29,000 equals to 0.9 as it is. FU we have 410, gamma M1 1.25. Pitch we need to calculate from here. And DN we already calculated as 18. Multiply by thickness, I have considered 10 mm as a thickness. Okay, for a first bolt. So I got a pitch distance as a 27.8 mm. Now let's consider the another figure of another situation of the pitch, which is 2.5 into diameter of the hole. Okay, so 2.5 into bolt diameter is 16, so it becomes 40. So let's consider the highest value of for the pitch, which is a 40. So I am providing the pitch distance as a 40 mm and minus 10 will be the edge distance. So I am providing 30 mm as a edge distance. Understood? Now this is a step number 3. Now what is a step number 4? Calculate the VDPB. So to calculate the VDPB, we are aware this is a formula. Now in this formula, very crucial value is KB. So KB is a value of, KB value belongs to the lowest value become all 4 of this. Now we have all the values like H, DO, P, DO, everything we have. I have put the values over here. So H is 30, I have put it here. 3 into 18, 0.56. This become 0.49. Okay, this becomes 0.49. FUB into FU become 0.975 and 1 is as it is. So the KB is the smallest of everything. So you can see the KB value is, let me just check guys. Okay, so KB is 0.49. Okay, 0.49 is the smallest value. So I have considered KB equals to 0.49. So VDPB will be, put all the value, 2.5 into 0.49, D equals to 16, TP is the thickness 10 and FU equals to 410. Right? So I taken all 3 values divided by 1.25. So you got the VDP equals to 64.29 kilonewton. So now understand your VDSB is 29 and VDPB is 64. The design which we have done based upon this value, it means it is the lowest one and hence our design is fine. So what is a design? So design is we are going to provide 4 bar of 16 mm dia bolt at 40 mm of pitch and 30 mm of edge distance. So this is a design and this is your answer. This diagram is your answer. I hope you understand this numerical very well, and I ask you to please do subscribe my YouTube channel because I take lots of effort to prepare this kind of channel for you all. Right? I hope you like this video. Have a nice day. Bye bye.